Hello everyone and welcome to this video on combinations. Before we start discussing combinations, it may be worth noting that you will need to have a prior knowledge of factorial notation. If you are unsure of factorial notation, please see our previous YouTube video. Otherwise, let's learn. A combination of objects is an unordered arrangement of those objects. Let us consider A, B, C. This can be ordered as A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and finally C, B, A. The 6 different ways ABC can be ordered, but since combinations are the unordered arrangement of objects, all of the ordered ways of ABC are considered the same. So just to clarify, we have 6 different ways of ordering ABC, but because combinations do not worry about the order of the objects, all 6 different ways of ordering ABC are considered the same when we consider combinations. Now let us imagine we have a group of n objects and I choose at random R of those objects. The number of possible combinations may be calculated by finding NCR, or as you can see we write it in brackets as sort of NR. But we say N choose R or just NCR. So let's look at the formula. NCR is equal to n factorial divided by n minus r factorial times r factorial. It may be easier to see with an example how this works. Let us just go back to ABC, or in this particular example, ABCD. Imagine 4 students, Alex, Ben, Charlie, and Dan. If we wanted to select one student out of the 4, there are 4 combinations. We have Alex, or Ben, or Charlie, or Dan. And we can see that 4 choose 1 is equal to 4 factorial over 4 minus 1 factorial times 1 factorial, which is equal to 4 times 3 times 2 times 1 divided by 3 factorial times 1, which is equal to 24 over 3 times 2 times 1 times 1, which equals 4, which is what we found: Alex, Ben, Charlie, or Dan. Let's imagine now we want to select 2 students out of the 4. I could select Alex and Ben, or Alex and Charlie, or Alex and Dan, or Ben and Charlie, or Ben and Dan, or Charlie and Dan. There are 6 combinations, and on the slide I've represented them as AB, AC, AD, BC, BD, or CD. 6 combinations. So looking at the maths, we can write this as 4 choose 2, 4C2, is equal to 4 factorial over 4 minus 2 factorial times 2 factorial, which is equal to 4 times 3 times 2 times 1 over 2 factorial times 2 factorial, which is equal to 24 over 2 times 1 times 2 times 1, and that comes out as 6. 4C2 is equal to 6, and as I've shown, if we select 2 students from 4 students, there are 6 possible combinations of selecting those students from the group of 4. Okay, so now let's look at a real life example. In korfball, there are 8 players, 4 men and 4 women. Let us imagine the coach has 10 women on the team and 4 must be chosen to play in the team. How many combinations of women are available to coach for the coach to select in the game? So in this case, there are 10 objects, and in this case, women, and we are choosing 4 of them. So our calculation becomes 10C4, which is equal to 10 factorial over 10 minus 4 factorial times 4 factorial, which is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 factorial times 4 factorial, which, when you put it into a calculator, equals 210. In summary now, it may seem as though combinations requires complicated calculations. However, there is an NCR or NCHOOSE-R button on our calculator that we can make use of. It is most likely that going forward we will use the NCR button, but it's nice to know how we can calculate combinations from basic fundamentals of factorial notation. Thank you for listening, and please feel free to email me if you have any further questions on combinations. Thanks for watching again.